A warm welcome to everyone to my YouTube channel. I am Yashwant. Yes, my USN is 1V23EC 123. I am studying in Sri Venkateswara College of Engineering. Today I am back with a new concept called Concepts of Counters. Here, counter is a register which have capacity to count the number of clock pulse arriving at the clock input. Counter is a device that stores and sometimes displays the number of times of particular event or process occurred, often in relation to a clock. Counter circuit is usually constructed of a number of flip-flops connected in cascade. Counter represents the number of clock pulse arriving, and on arriving of each clock pulse, the counter is incremented by 1. In case of down counter, it is decremented by 1. Types of counters. Counters have two types. One is up counter and another one is down counter. In up counter, the decimal we count from 0, 1, 2, 3, 4, 5, 6 till 15. In binary count, it starts from 0002 and 001, 0010, and it's keep on counting till 1111. As usual in down counter, the decimal we count from 15, 14, 13 in the reverse order till 1. In binary also it repeats from 111 to 000. It's a reverse process of up counter. Binary counter only gives the output of binary number sequence, means binary counter will give only 000s and 1s. A cascade of n flip-flops can be used to configure a counter up to a modulus of 2 to the power of n. Modulus means the total number of states. Thus, cascade of 4 flip-flops can be used to configure a counter up to modulus of 16. Means 4 flip-flops have capacity to configure modulus 16. Means 4 2 to the power of 4 is 16. A binary counter up counter counts from 0 to 2 to the power of n minus 1. Once the terminal reaches the max count, it again repeats the sequence, means counting from 0 to 2 to the power of n minus 1 again. The binary down counter counts from 2 to the power of n minus 1 to 0. When the terminal reaches the max count, it repeats again 2 to the power of n minus 1 to 0. 4-bit binary ripple counter. Asynchronous counters. The 4-bit binary ripple counter configures using positive edge trigger T flip-flop is as shown below. The 4 flip-flops are connected. The input to the counter is a count enable signal and a series of count pulses applied to flip-flop. Thus, a long count enable signal is logic 1. The Q of 0 output flip-flop toggles on each positive edge of the count pulse. The clock input of the remaining flip-flops is connected to Q bar output of the previous flip-flop. These flip-flops change their state during 0s to 1. The transition of 0 Q bar output, which corresponds to 1 to 0 transition of Q output. Since it is a 4-bit up counter, its modulus 2 to the power of 4 is equals to 16, and its continuous sequence is 000 to 1111. In binary, the output of counter appears at the Q output terminal of 4 flip-flop. The binary counter is known for as synchronous binary counter. The setting problem associated with ripple counter is overcome in synchronous counter. In synchronous counter, the count pulse are applied directly to control input C of all clock flip-flops. Observing the counting sequence, we find Q naught totals with every clock pulse. Their output totals whenever all the lower order flip-flops outputs are 1, thus all lower flip-flops output can be ended to enable the total of the given flip-flop. When count enable line is logic 1 and AND gate output will be 1 only. When all previous flip-flops output are 1, these output will turn to be fed to T input. The flip-flop those input is a logical one totals at the next clock pulse. The main drawback of this counter is as the number of stages increases, the number of input to AND gate also increases. The main drawback of this counter is as the number of stages increases, the number of inputs to AND gate also increases. Here, counters based on shift registers. The overall operations of digital system is divided into a sequence of time periods. There are two counters based on shift registers. One is ring counter, second one is Johnson counter. Here we discuss about ring counter. The ring counter is a circular shift register which is initialized such that only one of its flip-flop is in the first stage while the others are in zero stage. Upon the occurrence of each count pulse, the one shifted around the register. The counter, the ring counter consists of n flip-flops has only n states. The mod 4 ring counter configured using a circular shift register is as shown in figure. Next, Johnson counter. A variation of ring counter is the switch style counter as shown. Here Q outputs the last flip-flop is provided as input to the first flip-flop. An n-stage Johnson counter has two n states. The two input AND gates is sufficient to identify the decoder logic. The mod 8 twistor ring counter is as shown. Thank you guys. Thank you for watching video. Please like and subscribe for more videos.